Hey, it's Mike Waters, and welcome back to the Mystic Smoker Shop. And in this episode, episode number 2 of our 250-gallon smoker build series, we're going to cut the doors. In the last episode, episode number 1, if you have not seen that, I'd recommend going back and checking that out. We did the layout on the tank and even marked the 2 end caps for center line. For the collector end, in this case over here, and the firebox end over there. This happens to be a left-handed tank, so it puts the firebox on the different end, or the other end. Our goal here in this episode is to, of course, cut the doors. We will initially leave small nibs in each of the 4 corners of each door panel all the way around, and then we will put our vertical door bands in place and even tack them in 2 spots to the actual tank. And then we will nib the corners loose and put our horizontal bands on, our 4 horizontal bands. In this case, we're using 1/4 inch bands, both the vertical rolled and the horizontal bands. And some people ask, or I get this question all the time, Mike, why are you using such substantial bands? In my experience, door bands perform a few functions. Primarily, if they are rolled precisely and of substantial material, like these are, 1/4 inch by 2 inch, then they fit the tank precisely, and when you weld them in place, that helps provide some additional stability for this door panel when we finally cut it loose. Also, being 2 inches wide rather than, some guys will use 1 inch or whatever, half of that, 1 inch of that 2 inch width hangs over and provides a good surface for the 7/8 inch wide Nomex door band material or door seal material. I always use door seal material in my cookers. These cookers are built to be high airflow cookers. Of course, leaks are the enemy to a high airflow system. You don't want cold air entering somewhere that it doesn't need to be entering, other than through the firebox on that side. So we'll put these door bands on, and then even put the horizontals on. So to cut the doors, I have come full circle back to what I was using years ago, and that's a 4.5 inch grinder to cut the doors. Guys ask all the time, Mike, why don't you use a plasma cutter or a torch, or even the cold cut saws that you used years ago? And here's my very quick explanation. Years ago, I started out with a 4.5 inch grinder. We were using 1/8 inch disc, which were pretty thick. It did fine, but it was slow, very slow, and you would go through a lot of disc. Then the 1/16 inch thick disc came out, and that was a lot better, but still not that great. I fell for the height of plasma cutters, the nice sexy plasma cutter. And in my opinion, for building cookers, you do not need a plasma cutter. I have a very nice plasma cutter, and I very rarely use it. About the only time that I do use it is to cut out the very rough hole for the firebox throat there. But I used plasma cutter for a while. I did notice that I was getting some heat induced into the metal panel and into the tank, and that was causing some distortion. My rate of door failures, and by door failure I mean when a door flexes a little bit, or twists, or curls a little bit, just a tiny bit, like a potato chip or something like that. I know potato chip's kind of an extreme description, but a heat-induced door flex is not uniform. It will be more on one side than the other. Often it'll have just a little bit of a twist in it. So I don't want to put any heat in the doors that can reduce or increase my odds of a door failure. I want my doors to fit just as good as I can when I cut them open, and putting extra heat into the tank and the door just increases your odds of having issues. And as we discussed in the layout video, of course, we want to get away from the bunks and we want to get away from this horizontal seam. And also, we don't want to be putting any heat in there that we don't need. Ultimately, after that, I moved to the cold cut saws, which worked very, very well for a while. I have even a large one and a small one, and they'll cut a pretty precise line. But it is kind of difficult, and it takes some practice, particularly on the horizontal cuts. These are not as bad, the verticals are not as bad, but the horizontal cuts are very difficult to stay straight. And unlike cutting, say, with a skill saw on a piece of plywood, if you get off the line just the tiniest bit, or see yourself even coming off the line before you actually do, you can kind of steer that back over a little bit of distance and then get it back on course. In a metal situation, that is very, very difficult, and you will almost always pop some teeth off of the blade when you start pulling it back. If you don't pop them off, you're certainly degrading them and reducing the effectiveness and the lifespan of the carbide teeth, which are very, very fragile. So those teeth or those saw blades got very, very expensive after COVID. And that was when I moved away from them back to the 4.5-inch grinder, and I was pleasantly surprised to find thinner cutting disc out there. So this is a 1.2 millimeter cutting disc. It is so thin, and I have used this brand for several years now, and of course I've tried others. Of course, these people don't pay me, and I don't even know who they are. I don't even know if I'm pronouncing the name correctly. But I have found that this blade is working great for me, and I get good longevity out of it. I get a nice, very thin cut, which cuts very quickly compared to the thicker blades or the thicker disc. And knock on wood, I have used hundreds of these, literally hundreds, and I have not had one come apart. Of course, I probably just jinxed myself, so we'll have to see. So again, I have come full circle back to using these discs. I find that they are very easy to drive straight, and what we will do, and I'll bring the camera in and demonstrate how I do this, how I make the cuts, but we will start off making a skim cut right along the line, and you'll see that we're actually driving the grinder, driving the disc to stay exactly against that blue line. And when we're done, you'll see, and I am always impressed with how straight and how accurate of a line you can get. Even more accurate than the cold cut-off saws, and certainly more accurate than the plasma cutter is going to be. The plasma cutter is not going to be a nice smooth line, and you know, unless you're running a good guide, you know, you're going to have, you know, whatever movement your body induces into that, and get a little bit of a jagged line. And even with a straight line fence, which I did that for a while, I would tack a piece of angle iron up here or something else, you know, to use as a guide with the plasma cutter, and you know, tack a band over here and use it. Even then, it's not as precise as you will see this, and it's certainly not as clean a cut. You have to go back with a grinder and grind all that smooth, which isn't that big of a deal, but it's just not as nice as these. And with a thin blade, it is pretty quick. So my clock is on the wall there. We'll put the camera over here so we can kind of keep an eye on how long it actually takes, and we'll keep up with how many discs that we use, just to kind of see how much it's going to cost. I think last time I bought these, they were like 35 cents each, the way that I buy them. So that's not that bad. We'll see how many we end up using. I know for a fact it's going to be far cheaper than using the cold cut saw. And of course, essentially, other than consumables, there's very little cost to using a plasma cutter. So anyway, let me get set up. I'll rearrange the camera and obviously turn the fan on so that we can get some of this dust out of here. I use 2 different types of PPE. while I'm using the grinder. Now, you will see me through these videos. Sometimes I will just use a little face shield to protect my face or my eyes from flying debris, if that should happen, if I'm making just a small cut or a small grind or something like that. But if I'm going to be using either the sanding disc or the cutting disc for any amount of time, you'll see that I use the full face mask, and if it's a very long time, I'll even go pull the Piper system out of, it's got the filter that sits back here. I do a lot of these, so I have this system. It's expensive. I've had this one for several years. As you can see, it's kind of, it's got some wear on it, and it still works perfectly, but you certainly don't need, you will see me wearing this just because I have it, and it's more comfortable for me, particularly when it's warm out, because it blows the cold air through and it keeps me a lot cooler up here. But I will either use a full face mask if I'm going to be doing a lot of cutting, or that system, because you will see if you're doing a lot of cutting, not only are you getting the disc material floating through the air, but if a beam of sunlight is coming through the window or something like that, you can actually see tiny little sparklies flying through the air, and those are little pieces of metal. Even 3 or 4 or 5 minutes later, they are so small and so light that they are actually floating still through the air. So I wear a full face mask, not just to protect myself from obviously the flying metal that you see as sparks and such, or the potential for something to break, but also to keep that metal dust out of my eyes until the large fan has a few minutes to pull all that stuff out of the shop. So you'll either see me use one of these two systems if I'm going to be running the sander or the grinder a lot. And as a matter of fact, let me grab my little magnet off the wall. This is a, I don't know if you can see this, but this is a little, little magnet. And I just put it on the wall, the metal wall of the building over there. And it just sits there. Every few months I'll wipe it off, and it just gives me an idea to see how much stuff is actually floating through the air. So it's on that end of the shop where I don't, sling a bunch of metal when I'm running the grinder or something like that. So it's a clean area of the shop, basically. And over a period of months, you can see, and I'll try to zoom in later, that this metal dust, which it's metal because it's sticking to the magnet here, and it is so fine that you can't even feel it. It's just like talcum powder. So it's incredibly thin, and it is stuff that this magnet has just pulled out of the air over there against the wall. So that always amazes me. It looks like a lot, but it's been sitting there for several months. But even then, that is stuff that would be going in our lungs, and certainly going in our eyes, and those little almost microscopic, you can see the powder, how fine it is, but that is actually metal powder because it sticks to the magnet there. So that stuff is incredibly fine, and it gets in your eyes. And I find that if I don't use that mask, one of the two, and I am grinding or sanding a lot, because I use the sanding disc as well rather than a stone grinder, I find that a day later or maybe 2 days later, my eyes are real itchy and scratchy, where that stuff has just gotten in there and irritated your eyes. You won't really know it when you're doing it. Even the same day, I don't even feel it, but a day or two later, it takes 2 or 3 days to even get over it at that point. So pretty interesting little bit of trivia there. All right, let me go ahead and get set up. Get me a long sleeve shirt on, of course, and I may even cover a couple pieces of equipment. I usually position the tank to where I'm going to be throwing stuff, the sparks and everything off the grinder, away from any sensitive material, so just keep that in mind. I know that, and I'll get some guys who say, Mike, why do you even have equipment in your shop that's sensitive to dust if you're welding and grinding? Well, I just don't have another place for it to be, so I have to spend time cleaning that equipment so that I don't have problems with it. And I may even just throw a sheet over, or I have a couple of blankets that I just throw over. So if you see all of that in the background, that's what that's about. So let me get set up, and we'll be back and actually start some cutting. All right, the sound quality is going to be poor because the fan's on, and obviously I've got Hummin on. But again, essentially what we're going to do is do a skim cut, and then make subsequent cuts that get just a little bit deeper. And you'll see that it's easy to drive this thing. So I forgot to look at the clock. Let's just round. I'd say that we've been doing this 3 minutes, so we'll just round 3 minutes ago. Alright, so that is a very, very nice cut, and if you notice, there's no heat induced into it, and it took us 4 minutes, so that's not bad. 4 minutes to actually make the cut. So 20 minutes and 2 blades or 2 discs. Alright, so it looks like we went right at 1 hour and used, for all intents and purposes, 2, 4, 5, and 6. So there we are, 6 discs in an hour to get the doors cut, and they do look good. So I'll get cleaned up a little bit, which, you know, it does make a mess, and we'll get set up to put the vertical door bands on. Alright, so we got the doors cut, and they look okay. This is they're okay. So far, we really don't know exactly what the door's going to do until we nib the corners loose, but this one's looking pretty good so far. It's not the best that I've seen, which gives us a good example of a tank that was over-rolled. In other words, it was rolled just a little bit too much. I've got the door overlapping right here just a little bit. Of course, the corners are still intact, so these are going to be, the corners are still looking perfect, but right here, the tank is actually dipping in right there. I may be able to roll it back so you can see that better. And it's about 1.5 millimeters. It's not bad. Let's see. So, yeah, it's a little less than an 1/8 inch. This one is about a 1/16, if that. So that's not bad. All right, so if we take a straight edge and run it across here, stay off the weld, of course, because that'll hold us up. I am still perfectly flat running across here on the door panel itself. If I come down below the door panel, I can see that that variance is in the tank. So I'm touching here and I'm touching here, but I've got a dip right there. I'm not worried about that style of tank flex in this case. The door is still perfect, and that's what I tell a lot of guys. They'll start moving their door to match the tank when it's actually the tank that is moving. And the tank is a far easier thing to change than the doors. So, and that one is doing the same thing. So this is a good example. We've got about a 1/16 gap right there. I'm touching here, touching there, and a little bit of a gap there, but put it up here on the door, and I'm completely flush all the way around. So that's a good sign. And it didn't do it at the top. That still feels perfect. So that's good. That's a good sign. So quick tip. Take a piece of paper or a business card, or in my case it's a little machinist ruler, and just make sure that you can get all the way around. That's where that tank's a little tight right there, and that goes all the way up. Run all the way around to make sure that your cuts are complete all the way around. I've been doing this for a long time, and it is very rare that I don't find a tiny little spot that I missed. As a matter of fact, this spot was right there. So when I did my test, it hit a hard spot right there, and when I finally cut that loose is when this sprung down. So you want to make sure that you get all of those tiny little areas that you may have missed out, because once we put that horizontal band on, and it is a nightmare to try to pull this off, and and you can't. You have to cut the hole out for the firebox and crawl in with a Ziz wheel and hit it from the inside. Either that or just take your door band right back off, which isn't that big of a deal, but I would much prefer not to do that. So we've still got our corners in. I'm going to get set up, put our vertical bands on right quick. Then we'll tack the vertical bands to the tank to hold the door in place. Then we'll go ahead and nib these corners loose and then put our horizontals on. So let me get set up for that. I'll be right back. All right, so our door bands need to be 2 inches shorter than this cut right here, from the top cut to the bottom cut. If I remember correctly, it was like 20 1/8, 20 1/4, something like that. I don't recall. But if we measure that opening there, we have 20 and it's a good full 3/16. So let's call it 20 1/4 from this to this. And remember, our top band will come, or vertical bands rather, will come down to 1 inch before this bottom band here, or the horizontal band. So the horizontal band goes all the way to the end, and the vertical band does not. It stops and meets that horizontal band. Of course, that horizontal band is 2 inches wide, split that in half, you have 1 inch. If we are 20, and get back down here. If we are 20 1/4, that means these bands need to be 18 1/4 long. It will give us 1 inch at the top, inch at the bottom, and the horizontals will go all the way over. So let me cut these rascals here to 18 1/4 and weld them on. Okay, so we've got the door bands on. That's kind of like watching grass grow, so I wasn't going to put you through that. The vertical door bands went on very easily, and the horizontals, of course, they're just cut to length and weld them on. A couple of tips: you definitely want to tack these. You can see the top band is tacked in 2 places there. And the reason you do that is because if you weld these without a tack on the other side first, you will pull that door band back. So just make sure that you do that. The same with the verticals there. Of course, the verticals were tacked to hold our door in place, right, while we nibbed the corners loose. So those doors are just held in there by those tacks, and tomorrow morning when we get started again, we will go ahead and cut those tacks loose and then pull the doors out and start prepping them for hinges. Now there is I debated even bringing this up, but there is a unique feature to Mystic Smokers cookers with respect to their horizontal door bands. If you notice, that horizontal door band matches the curvature of the tank and the vertical. This is a piece of flat bar, which is typical. And you can see it experiences what is called the horizon effect, right? Because it's flat, the tank is round, it always rocks. My horizontal bands on all of my cookers are rolled slightly. I don't know if you can see that, but they are rolled slightly so that they match the curvature of the tank. So that's pretty cool. And that helps cradle that door seal material better, so that it fits better. And with flat door bands, you just never know. I mean, it's very difficult. There's a lot going on. To get that different split half and half is kind of a pain in the neck, and you're only really touching right there in the very center, right? If you get it that way, or if you do it over here. So at any given point, there's only, I don't know, maybe a ½ inch or so of the band actually touching the cooker, where some metal shavings up there, where these door bands obviously fit very flush all the way across. So it's just a better fit and finish, and just something unique to my cookers. I roll the horizontals to match the verticals. So we'll get started over again in the morning, and I'm pretty happy with the way it's coming along so far. So we'll hope everything keeps going smooth, and I'll see you in the morning. All right, it's time to turn the tank to get the doors up towards the top so that we can go ahead and cut these tacks loose and free the doors from the tank. But I don't want to do it here because these doors will fall, and you know, I've got multiple dings in the floor where they've fallen and chipped the floor, and I've had one fall on my foot before. Luckily didn't break anything, but it was sore for a while. So I roll the tank back, which I'll have to release it from its tank stop down there here, and roll it back. But I did go ahead and put another tab back here on the back side, and I like to put that one at about the 3 o'clock mark there, so that I can swing it back for a few other processes during the build and get the doors basically up high so I can do things with them, and that works out about good. So there will be 2 more tabs down here, and they'll be in, you know, in this area down here. I'll even put one on the firebox side, so that when I get to those elements or those stages of the build, I can go ahead and lock the tank down using those tabs as well. So go ahead and put a decent weld, not that my welding is good there, but don't just tack it. Go ahead and weld those tabs on good, because like I said, this is a 750 pound, probably close to 800 pound tank now, and it just gets heavier and heavier as we go. So there will be a lot of weight on these tabs. Don't tack them. They will pull off. So go ahead and weld you a good tab on there. It's super easy to cut those loose with our cutting wheel, our 16th or 1.2 millimeter cutting wheel, without cutting into the tank. Just cut the weld and then use a sanding disc and cut it back smooth, and you'll never even know that tab was there. It's no problem at all. When I say sanding disc, I mean on the grinder, these I like to use 36 inch, and it's got the little plastic base on the back of it, and then, you know, they change out pretty easy. I'll show those a little bit later, maybe even put a still shot in about here in the video. So let me go ahead and get this tank rolled back, and I'll cut those doors loose. All right, so let's get a close up and see what I'm talking about. You just want to barely cut into that weld. If you can see here, I accidentally touched right there, but I didn't really cut in. That's not that big of a deal. I can fix that, and we'll never even know that that's there. But typically what you want is just where you get through the weld, just barely, and not go into the tank, or maybe even leave the tiniest little bit of paper thin tack left, part of the tack left, so that you can just pop it loose with a hammer. So let me go ahead and pop these loose. All right, so we get to look at this tank for the first time on the inside, and we can see, since it's rolled back, the bottom is going to be over there exposed. So you can see where the water, after washing it, sat in the bottom. Of course, see, it's rolled back. This is the 12 o'clock line. So exposing the very bottom where the mercaptan sat, that, you know, over the years, that layer of mercaptan, the oily, greasy substance that the gas company puts in the propane to actually give it odor, because propane doesn't have an odor itself. It's the additive, the greasy, oily additive that they put in it that we smell. And although there was no gas in here until I neutralized that smell, it smelled strong of propane still, or of mercaptan. And you can see the greasy stuff that has run down from where I cleaned it off. And I didn't video cleaning the tank out. I probably will at some point, but my 7 or 8 step process for cleaning the tank out is on the mysticsmokers.com website under the videos and resources tab, and it's pretty straightforward. In a nutshell, I get a gallon of bleach, a gallon of the cheapest dish soap I can get. A lot of guys will use Dawn or some other elaborate dish soap to handle the mercaptan issue. I have found that the cheapest stuff that you can find does just as well as the most expensive stuff you can find. So I dump a whole gallon in, and I'll put a steel shot here in the tank, and then I will dump about a quart of bleach in the tank, and fill it to about 5 or 6 inches. Of course, that's going to bring it up just a little bit higher than where that water was sitting there, that water line there, or that greasy mercaptan, what used to be the greasy mercaptan line. And at that point, I will either take a stick and stick in one of these holes here and kind of swoosh back and forth that very shallow water to kind of break that greasy mercaptan up. And you can see where it has flowed down from where it was sitting because it's all neutralized and broken up with the dishwashing soap and the bleach. So what I prefer to do, though, if you can get in one of these bigger holes, is I will take the pressure washing wand. Remember, it's got the tip on it that's big enough. It requires one of those bigger holes. I'll take the pressure washing wand, stick down in there. Don't put your face over one of the others because it's going to blow bubbles out and get all over you. I'll take the pressure washing wand, stick it down in here, and just imagine, of course this is going to be up on top, right? Because it's still sitting on either the ground or on a trailer. I like to do it on a trailer. And imagine that line, which is the bottom of the tank over there, about 10 inches or 12 inches wide, and just take the wand and spray that whole area down there trying to break that up. That's why nothing is stuck to the floor and it is perfectly clean where I washed. So gosh, I probably could have come up the wall and got a little bit of rust off, but you can see how much rust I knocked off the very bottom and all of that. So anyway, that's my method, and then of course drain it out. So this tank is supposed to be 0.250 shell thickness. Of course, shell being the cylinder itself. I've cleaned off a spot right here, so no burr on top, no burr on the bottom, and I've actually cleaned off with the sander a little spot right there, so I'm not taking into account any of that rust flake right there. And this tank is actually, find my spot again where it's cleaned off, almost 280, 0.280, so it's 0.278 and probably a tenth or so. So this tank's a little bit thicker than, and that's the thinnest spot I found. There are some spots that are a little bit thicker and some spots that are a little bit thinner. That one's got, I'm hanging on the burr right there. So yeah, that's a pretty thick spot right there, 285, and there's no burr right there. I've already taken that off too. So the thinnest spot that I found on this tank is 0.278, so that's good. This is a real good tank. I'm real happy with it. Cuts look great, and they are super straight when you look down. So I am just very happy with the performance of those really thin blades. All right, so we got that flake rust off the inside of the door. That's going to be a lot easier to work with throughout the build than having that that rusty, dusty flake there. I just deal with it inside the tank throughout the build. There'll be a few spots that I'll clean off, you know, to put the grate runners and that sort of stuff. But for the most part, the inside of the tank just stays rusty. But since I'm right here with the doors and it's easy to get to, I go ahead and clean those up. And it'll make it easier to put the little bung on right there for the door gauge, temperature gauge a little bit later on. I use bungs. I don't use the little nut on back of the Tel-Tru gauges. But so let me go ahead and get the other door cleaned up, and then we'll start talking about the door band material, or the door seal material, the Nomex door seal material. So let me get the other door cleaned up and I'll be right back. And there's another little thing that I wanted to mention right quick. This door sitting on a flat surface should not rock from corner to corner at all, and this one does not. It fits perfectly flat all the way around. If it does, that means your door is flexed or twisted just a little bit. And in that case, it's going to be very difficult to get the doors to seal well. But I'm always very nervous until I check it on the table like this and see that it is indeed perfectly flat. So that's a good door. We like that. Okay, so the next step in putting our doors on, or at least for hinge preparation, is to put the little pads of door seal material on the underside of the bands, the door bands, to space the door up off of the tank just a little bit, to basically to simulate this door band material being on all the way around when we finally finish the cooker and paint and do whatever we do. We don't want to put this on yet because we still have a lot of stuff to do, and the cooker will get sandblasted again at the end, or at least that's the way I do it, and I don't want to be sandblasting that stuff. So I put little pads on just to space the door up off of the cooker, and it'll make more sense when we get over there in just a minute, before I put the hinges on. Because if I put the hinge on now, with the cooker sitting flat on, or with the door sitting flat on the cooker, when I raise it up and put this door seal material on finally in the end, the door won't close all the way. It'll hold up probably about that much because we haven't allowed for that extra space there. So that's all those little squares are, and I just cut them off about 1 inch long and space them out. And then I generally put 1, 2, 3, 4, 5. This one's got 6 across the top, and I don't know. You just space them out through there. And again, all it does is lift the door off the tank just a little bit. This material is 1/8 thick right now. It will crush down to about 1/16 of an inch. So I like to put it on the tank, set it down onto the tank on top of these pads, let it sit overnight, and I'll even take a strap and strap around the tank, kind of hold it down, suck it down to kind of collapse these down a little bit more. And then tomorrow I will put the hinges on, and from there forth it will open and close perfectly. So let's move over to the tank and go ahead and get this in position, and also we'll put our little spacers on. I'll show you what that's for in just a minute. All right, so I have got this door positioned. You can see the shipping strap or the tie-down strap holding that door on, and that one's on tight. I'd actually filmed that one, but the volume didn't work out, so we'll use this as an example. So I have just sat the door that I just put the pads on in the hole. That's all that I've done. And that would be great. We could go ahead and mount this door here. The problem is we want this door to have some play back and forth. You can see that I can slide it back and forth, and I can also push it forward and back. Well, it's very difficult to kind of split the difference and get the spacing just right, because what we don't want is to have our hinges on and then shut the door and it be too close to one of the sides or too close to the bottom, and we have to go back and grind that away. So the way to avoid that, or to get it perfectly spaced, is to just take some little wooden spacers, and I just have some little scrap 3/16 wood here, and I will take a piece of tape and tape it to the inside lip of the tank, probably here and here and here and here, and that way I can pull the door down against these, and I can pull the door over against these, and that way I know I have 3/16 clearance on both of those, and that's probably going to be about the same there because that's what I widened the holes out to. Let me pull this door out of the way and I'll show you what I'm talking about. All right, so this little strip right here is just about 3/16 thick, and I'm going to tape it to right there. But I need to, I should have already done this, I'll do it right quick. Take my sander and just sand a spot there on the inside, here, and there, so that the tape will actually stick. So give me just a minute. All right, so I've sanded some spots on the inside here, and there, so just to get the rust out of the way so the tape will stick. And just take a piece of tape, get your glasses on where you can actually see. And just set that piece of wood there on the lip and just tape it down real good. I generally put a couple of pieces of tape just to make sure I don't push it off when I'm putting the door in place. All right. All right, now we should be able to push this door about the width of one of those spacers, which that's perfect right there. So I'll pull the door all the way to me, and then we should be able to push it up and then pull back, and it does. There we go, that's perfect. So we're going to pull it down and then pull it over. And then there we are. That's exactly where we want that door to sit. And both doors are in the perfect position to put the hinges on at this point. So I'll put another strap on this one, and then I can roll the doors. This one's already cinched tight. I'll move this back just a little bit. So this door is already cinched tight real good. And it's just got a little bit of pressure on, and I can see that in the last hour or so, this one has actually even gone down just a little bit, so that's great. And that'll be perfect, ready to weld. I could probably go ahead and weld it now, wouldn't be a problem, but I think I'm going to do it tomorrow morning and knock them both out at the same time. All right, so I've got the hinges welded on, no need taking you through that. Again, we've seen that in other videos. One quick little note, I do like putting the hinge blades about 3.5 inches from the edge of the door band. In my opinion, that just looks kind of symmetrical. It's not really a big deal at all. So you have seen me put the hinges on in other videos, so you know how to use a threaded rod. If not, I'll go over that real quickly here, just a recap, not in detail. I like using the threaded rod to keep all of the components of the hinge, the Mystic Smoker hinge, in place while we're welding them on, and also to keep them in perfect alignment. You can see that these hinges are perfectly aligned because they're held in place by that threaded rod. So the hinge itself, if you're not familiar with it, is a 3-part hinge. There's 2 small blade parts and then the larger part. I like to use a stainless steel shim between the parts. You don't have to use that shim. I just find that it makes a little more elegant part here. And it does provide some corrosion resistance, so your actual parts are not actually rusting together if the system sits outside in the rain and the weather and that sort of stuff. And as a matter of fact, because guys have been asking me for years where to source these stainless steel shims, you know, they're not that expensive, so I just go ahead and add them with all of the hinge orders at this point. I just started it this past year, so all of the hinges that I sell in the future will come with those shims. So it goes together very simply. Just put the blade, the shim, the blade, the shim, and then again wrap it up with another small part, and then add the nut to hold it in place. Another nice feature about using the threaded rod is it gives you some adjustability. So if I'm at 3 3/4 inch, all I've got to do is simply loosen one side and then move the hinge down, and it moves back and forth fairly easily. And then once you get it in position, just take a pair of pliers or a wrench or something and just gently snug those down. Make sure that your back parts are all the way down against the tank. Make sure your front parts are against the tank. Double check it, triple check it, walk away from it, come back and make sure that you're absolutely correct, and then go ahead and tack them in place. I like to put a tack here, a tack here, a tack there, and a tack there, very small, and then do the same thing up there. Get everything exactly where you want it. Stand in line on one end of the tank and look all the way down across both sets of hinges and make sure that they are in alignment with each other. I like to come about 3/16 of an inch off in the back, and that gives us plenty of clearance room over that 1/4 inch by 2 inch door band there. So that's pretty straightforward, and again, we've seen that in another video, so no need to go through that again. All right, so all we've got to do now is simply take a bolt that we're going to use to build with, and simply push the threaded rod out. And the reason I use a bolt to push it out so my washers don't drop down. If they do, that's not that big of a deal. You can always, realign everything. It just makes things a little bit quicker. And then, of course, I'll just snug that up, and I can use these bolts and nuts to position the door and hold it wherever I need throughout the build. We've got the doors cut, we've got the hinges on, and everything's working out great. Off camera, I'll pull these out and put the bolts in that I'm going to use throughout the build. I like to use stainless steel bolts and washers when I am done with the build, but throughout the build, I will be opening and closing this door, 20, 30, 40, 50 times. And stainless, of course, is notorious for galling up or seizing, so I use regular grade 5 bolts throughout the build. And if I ever need to open the door and just keep it in one position, that is very easy to do by just tightening those nuts up. I make sure I'll tighten both sides just as a safety precaution, but one side would probably hold it, and you cannot move that door now, so that's in a good locked in position. And if you need to move it at all, you can lock this door down wherever you need, and it'll stay in that position right there. So just a quick tip there. And that's a very, very smooth operating door there. Nice good thud when it closes rather than that clank where we would be hitting some metal. That means that we got our distances right all the way around. And nice smooth operation in the hinge. So we'll wrap this video up here. Make sure to give it the thumbs up if you got some good information from it. Share the video if you know a friend that could benefit. And if you haven't already, subscribe to the channel at mysticsmokers.com. And I will see you in the next video.